Welcome to this screencast. My name is Patrick and I'm one of the developers behind the Lagom service framework. In this screencast I will cover how to implement persistence in a Lagom service. I will introduce the concept of event sourcing. I will show how to implement that with a persistent entity, which is the main tool for persistence in the Lagom framework. After that, we will turn the events into a representation that is targeted for queries. The design of separating the write and the read side is known as the CQRS pattern. Before we start, I would like to highlight an important principle. Each service owns its data, and it's only the service itself that should have direct access to the database. Other services must use the service API to interact with the data, so no sharing of databases across services, since that would result in a too tight coupling. You may recognize this as a bounded context in domain-driven design terminology. Each service defines a bounded context. When I say service here, I mean a logical representation of a service. The implementation may be deployed on multiple machines, collaborating with each other in a cluster to build up the service. The support for persistence in Lagom is based on event sourcing. That means that we represent all state changes as events. Those immutable facts are appended to an event log. Nothing is ever mutated. To recreate the current state of an entity when it started, we replay these events. For example, user Alice is created. She adds Bob as a friend, then adds Peter as a friend, and then removes Bob. All these changes are represented and stored as individual events. In contrast, with the traditional approach, for example using JPA, you would only store the current state. So if Alice removes Bob, there is no information about that she ever was friend with Bob. The information is replaced and the full history of how we reached the current state is lost. Here are some advantages of using event sourcing. There is no need for advanced mapping between domain objects and database representation, since we only append events to a log. The history of how we reached current state is all in the stored events, so we get an audit log for free. We can analyze these events and turn them into important business information, perhaps things that we were not even thinking about when the events were created. We can get very good write performance since we only append the events to the data store. There are no in-place updates. It's rather easy to test. A given set of commands should result in a set of events, and those update the current state. We can also use the event log for debugging. If something bad happens in production, we can take the event log and replay it in another environment to understand how we reached the bad state. I have said that we only store events, and that the events are replayed to restore the current state of the entity. That's not the full story. To speed up the recovery process, we store a snapshot of current state after 100 events. Then the replay can start from the latest snapshot and only replay the events after that. This should be seen as an optimization. The old events are not removed since they may convey important business information. A persistent entity corresponds to an aggregate root in domain-driven design terminology. Each instance has a stable identifier, and for a given ID, there will only be one instance of the entity. One for Alice, another for Bob, and so on. Lagom takes care of distributing those instances across the cluster of the service. If you know the identifier, you can send messages, so-called commands, to the entity. The commands are processed sequentially by the entity. A command may result in state changes that are persisted as events. The persistent entity is also a transaction boundary. Invariants can be maintained within one entity, but not across several entities. Lagom has support for Cassandra as data store. It's a very scalable distributed database, and also flexible enough to support most of the use cases that reactive services might have. Let's take a look at how to develop a persistent entity. I will illustrate this with the friend entity in the Sherpa sample. This is how it looks like before filling in the implementation details. We extend the persistent entity class, and there are three type parameters that are needed: the command, the event, and the state. Let's take a closer look at these. Here are the messages, the commands that the entity can receive. You can create a user, you can get the full state of a user, and you can add a friend. Note that each command has a reply type that describes the response message for each command. We are using the immutables library to define these message classes. That is very convenient, but still optional. You can write them by hand since it's just PAGEs. They must also be serializable, since those messages will be sent across different nodes in the cluster of the service. Here we use JSON, which is our recommended format for both messages and stored events. Here are the events of the friend entity. Events are the things that we store, that represent the state changes. Here we have two events, one for user created and one for friend added. The third type in the entity represents the current state, the friend state. Initially it's empty, then the user contains ID, name, and a list of friends. We use JSON for the state as well, since it's stored in the snapshots. We need to specify the behavior of the entity, what it should do when it receives different commands. This is done by implementing the abstract method initial behavior. This is how to define the behavior when receiving the create user command. You can do validation and reject invalid commands, you can persist events, and reply with acknowledgement when the persist was successful. We define how the stored event should update the current state. That is done in the event handler. The event handler is invoked when the event has been persisted, and is also used when the persistent entity is restarted to recover its state from previously stored events. For this reason, it's important that the event handler only updates the state and don't perform any side effects, since you don't want these side effects when it's restarted. Here is another command to retrieve the user state. It simply sends a reply back without persisting. Such requests can be very fast since everything is already in memory, unless the entity is passivated because it has not been used for a while. To make it complete, we define the behavior for the add friend command and corresponding event. That is the full definition of the friend entity. Let's look at the usage of this entity in the friend service. The first thing that is needed is to inject the persistent entity registry and at startup register the friend entity type. Then to use it in a service method call, it looks like this. You need to get a reference to the entity with the method ref4 of the registry. There you give the class and the identifier for a specific entity as parameters. In this case, it's the user ID. Once you have the entity ref, you can send commands to it using the ask method. The reply is returned in a completion stage. Everything is fully typed, since we have defined the reply type in the commands. The persistent entities hold the state of individual entities, but they cannot be used for serving queries that span more than one entity. You need to know the identifier of the entity to be able to interact with it. Therefore, you need to create another view of the data that is tailored to the queries that the service provides. A friend entity knows the friends that were added. For example, Alice added Bob and Peter as friends. But what should we do if we need the opposite relation? The followers of a user, for example, who is following Bob? We can't ask all entities, that would be too slow. and we might not even know the identifiers of all entities in the first place. So we need something that would turn the events into a representation that is optimized for the query that we need. It would process the friend-added events and populate the followers table. This separation of the write side and the read side of the persistent data is often referred to as CQRS, Command Query Responsibility Segregation. A benefit of this pattern is the separation of concerns between the write and the read side. The entities can focus on the updating commands, and the read side can be optimized for various queries and reporting jobs. This separation is also great for scalability, since the read side can be scaled out to many nodes independently of the write side, and it's often on the read side that you need this massive scalability. I can recommend the Microsoft CQRS journey for learning more about this and also about event sourcing. Here is a great picture. It shows how the updating commands come into the write side corresponding to our entities, and the write side data store is updated. The changes correspond to our events, they update the read side, and the queries goes directly to the read side data store. How would we implement a query for the followers of a user? In the end, we would like to query the database, something like this method. Let's see how to develop an event processor that would populate the followers table from the stored friend-added events. We extend the Cassandra read side processor, and these are the methods that we need to implement. First, we must define which events we are interested in. That is done by specifying an aggregate event tag, which is essentially a class name or a string. This tag is also defined on the events. Here we use the same tag for all events produced by the friend entity, so our processor will receive all events. Let's get back to the prepare method later and first look at the define event handlers. Here we define what should be done for each event type. Here friend added. Let's fill in the implementation. Write followers is a Cassandra prepared statement. We bind some variables to it, and in the end we return the bound statements that will be executed for the event. We also bind another prepared statement that keeps track of the offset of the event. The offset is used when the processor is restarted so that it doesn't have to start from the beginning every time. Those prepared statements are initialized from the prepare method. This is Cassandra query language, rather similar to SQL. The prepare method is invoked once when the processor is started, and there you can do things like preparing statements or loading some state. It should return the offset, which tells where in the event stream to start. Then the event handler is invoked for each event. This is like a job that is running in the background that transforms the event into the representation that can be used for queries. Back to the service. Note how we inject the Cassandra read side and register the processor. This means that one and only one instance of the processor is always running on one node in the cluster of the service. The Cassandra session that is also injected in the constructor can be used for executing the queries. Let's see if it works. Start the Sherpa sample with activator run all. When all services have been started, we can create users: Alice, Bob, and Peter. Get Alice. Still rather lonely. So we add Bob and Peter as friends. And let's see who is following Bob. Alice. That's correct. One missing piece of functionality in the Sherper sample is that it is not possible to remove friends. For example, Alice wants to remove the friend association with Bob. That is an excellent exercise for you to complete. Download the Sherper sample and give it a try. You need to do the following tasks. Add the service method in the interface and the implementation of the friend service. Add remove friend command and the friend removed event. Define command and event handlers in the friend entity and also event handler in the friend event processor. I've not talked about how to write tests, but Lagom has some great support for that as well. So try to adjust the friend entity test and the friend service test. To learn more, you find links to documentation at GitHub. There you also find the Sherper sample. Make sure you don't miss our other screencasts that are covering the Service API and the development environment, and one demonstrating how to run your Lagom services in production with Conductor.